and thank you for joining us for this evening's virtual open house for the Software Engineering MPS and Certificate at University of Maryland, Baltimore County. By being here today, you are eligible to win a special open house scholarship bonus, which we will go ahead and pull at the end of our PowerPoint presentation and before our Q&A period. You do need to be with us at that time to be eligible to win. Without further ado, I hope that you enjoy the presentation, and I'll introduce Dr. Mohammed Samara, who's the Graduate Program Director for Software Engineering.
Thank you, Jeremy. Hello, everyone. Welcome. I'm glad you're with us. You selected one of the most exciting fields to consider for your graduate studies. So that being said, let's get started. So you came to software engineering, and in many regards, we believe software engineering is the new oil, the new currency. And our objective is to seek students from every corner of the globe to be part of this opportunity. It's an opportunity for you, and it's also an opportunity that is in high demand. You know, if we look at what countries produce, some countries produce textiles or fish products or food products or coffee or electronics. Software is something that can be produced by any country, by any region, by any nation, by anyone. And that's why it's important than ever before to pursue software engineering because of its sheer impact to our whole world. So it's important to understand what we mean by software engineering. Some students or some folks may think software engineering is programming or perhaps computer science. Software engineering does include programming and some computer science aspects, but it's different in that it's really about the whole entire life cycle of a software product. And we must carry on with a systematic, disciplined, quantifiable approach to the whole entire life cycle, from the creation to the operation and deployment and maintenance. In other words, we have to apply engineering to the software creation to be able to do software engineering. And we'll talk about that in a bit more details as we go through the presentation tonight. So, right, it's important to know that the job outlook for software engineers is tremendous. We already said software is everywhere. It doesn't matter what business domain you're in. It doesn't matter what government sector you're in, whether it's defense, whether it's healthcare, finance, the thing that we call data, right? The hottest field there is, perhaps maybe as hot as software engineering, maybe hotter than that, is enabled by software. Data by itself doesn't do anything. Data must be consumed and produced and transformed by software. So needless to say, software engineering is a highly sought after job. And if you look at some of the postings here in the area in Maryland, 29,000 positions for software engineering professionals. And more importantly, if we look at the projection for the next 10 years, that's an increase of almost 25%. That's a tremendous increase according to the US Bureau of Labor Statistics. So, and even further, the actual salaries for a software engineer practitioner is quite high, $100,000 or more, depending on the position. Looking further, you know, if you look at the US and where software engineering is, or where software engineers are, we are in a place where there's a high concentration of software engineers as a percentage of the workforce. In fact, the top 3 states are not California, not Washington State, not Boston or Massachusetts. You can see DC, District of Columbia, Virginia, and Maryland. Really the neighborhood, the region where University of Maryland, Baltimore County is. So you're coming to the right place, you're coming to the right lineage and heritage here. Again, looking at the numbers, you know, if we look at, this is just 2 years from now, we're expecting the number of developers to almost reach 30 millions. And looking even further to 2030, that's 8 years from now, that number is going to be about 45 million. So there's a tremendous need, and also there is tremendous shortage of software engineers and software engineering practitioners. I wanted to give you a flavor of job outlook by language. This is not to say that software engineering is about programming in a particular language, right? You can see here there are quite a few languages, and this is just a short list, right? This is what you learn in this program, how to apply these programming languages, how to apply these tools to solve a problem and to come up with an efficient, effective solution for that domain. So if you are creating an augmented reality or a virtual reality type of device, chances are you're not going to use JavaScript. You're going to use something else like Objective-C or maybe the C language or something else, right? A little bit about me. I'm a computer scientist and a software engineer by education and practice. And I have worked both in academia, in teaching and administration, and I also worked in the industry and built many software information systems and many applications and devices. I'm very proud of some of my accomplishments there. I had a long career at Harris Corporation. Now it's L3Harris, an Amulex Corporation in Seattle. I'm very proud of being a founding member for one of the newest universities in Florida, Florida Polytechnic University, of their College of Engineering and College of Innovation Technology. But I'm most proud of being here, establishing a very important and very needed presence for software engineering at UMBC. So hopefully that gives you a sense of what is software engineering. But why now? Why are you coming to it? Perhaps you already answered that question, but let's make sure that we understand why now. And in order for us to answer that question, we really have to go back about 60 years or so to the time in the 1960s when the US and other countries were racing to place a person on the moon, right? So this has taken us all the way back to the Apollo 11 mission at NASA. And during that time, software was not seen as a big part of that mission. It was all about hardware and telemetry and sensors. So what you see in this picture here is this young mathematician, Margaret Hamilton, who was in charge of doing some of the software aspects. And to her, she saw this differently. And she worked hard and diligently to ensure that software was part of that mission. And in fact, later in that decade, later in the 1960s, by 1968, 1969, it was very clear that without software, the mission to land a person on the moon would have not been possible. And in fact, Margaret is credited with coining the term software engineering. So let's pause for a second here. Software engineering is a young field. We're talking about a field that's about less than 60 years old here. It's younger than many other fields, including computer science. So let's fast forward now, right? We're not looking at these interesting devices at NASA back in the 60s. We're looking at this small device that you can buy off of Amazon or any other online outfits for about $100 or so. This device is crammed with sensors and widgets and wizardry, right? It's waterproof. It has a Wi-Fi radio. It has cellular radio. It has a camera and microphones and everything else, right? I'm exaggerating a little bit here, right? But if you look at that device, what makes it so special? It is not the sensors. It's not all the connectivity. What makes it special is the software that connects all that together. The software runs on the device from the user interface all the way to the chip level, all the way to the network stack. Without software, if the software does malfunction, this thing isn't worth anything. We call that a brick, right? So software is the magic that allows us to give this beautiful device as a safety measure for our children. Now let's take a sidetrack. In the 1980s and perhaps even the early 90s, our vision of software and computing was we're going to place these devices, these computers, we called them personal computers at the time, in every home and on top of every desk. And that's it. They will sit there. When you interact with them, they will do something. Then you go home or you go on to your business you go to the park or the coffee shop, and that computer is isolated, boy, we were wrong, right? We did some great things. We came up with these beautiful interfaces, right? You can see the Mac there and Apple with their innovation with user interfaces and design. You can see other companies like Compaq with their hardware abilities to be able to cram a computer into a carrying case. This is the laptop or the luggable of the 1980s. Yeah, it's quite an exercise, probably 30 pounds or so. Now, today, software is so important, so critical, because now it has entered everywhere. It's in the hands of everyone in terms of smart devices. It's in your pocket. It's in your purse. It's going to increase even more. So if we look at where we are now, it's about 6.4 billion devices. That's about 81% coverage in the world. We're expecting that to become 8 billion in about 4 years' time. In other words, software is going to touch every human on this planet, whether they are an infant, a 9-month-old, or someone advanced in their age in the 90s. And in order for that to happen in a meaningful way, we need participation across the world and diversity across the world in the way software is developed and deployed and maintained. And hence our mission to bring in students and to seek students from all over the world to be part of this mission. So going back to what we said about what is software engineering, it's really about the whole entire life cycle. Oftentimes, people think software engineering is about the implementation. This phase 4 here, just the creation, the coding. Clearly, there is coding involved, but it's really a lot more than that. Software needs to create meaning, right? And need to serve humanity, not the other way around. So that takes planning, it takes analysis, it takes design, and the other phases here. So what this program allows us to do is ready you to be part of these roles, right? Whether you're a product owner or a system analyst, there's a shortage of software engineers who are capable of being a product owner. Product owner is someone who envisions what this software is going to do, who bridges the gaps between the business and the users and the technical aspects of the device or the application that's being built. Analysis at different levels, from the system level all the way to the data level, right? And it goes without saying, design. The design is not just simply designing modules or components, but designing the system, the user interface, the interaction between these components, and how the user experience is going to be affected, right? How our demand for simplicity and ease of use has increased tremendously, and we expect software to do magic without us doing anything. So design is more critical than ever before. And yes, as I said, there is implementation, right? Whether you're developing the front end, the user interface of what the user can sees, or the back end, or somewhere in between, right? So we have this notion of a full stack developer, but also we have the need for technical leaders. Those are software engineers who are able to lead a team of engineers or teams of teams to build a product, because most software products that's worth anything are built by teams. In fact, that is one clear definition, clear delineation between software engineering and programming or computer science. You're building products that must be built by teams of people. In other words, software engineering is a team sport. And in order for the software to create meaning and change the world and serve humanity, it has to be reliable. Therefore, there has to be deliberate testing, quality assurance, and high quality has to be worked in from the very beginning. And that gives rise to software engineering tester, software quality engineer, and many other aspects, specialization within software testing. But that's not the end, right? Once we deploy version 1 of the software, we're not done. We must maintain it. We must update it. We must adapt it. That's something unique about software, that it gets adapted and changed over time. And some software can run for decades. I believe the oldest software running in the world is something like 70, 80 years old, right? How many products out there can claim that, right? Even durable products like an appliance do not run that long. So maintenance is an important aspect because we want software to be beautiful when it was created and continue to be beautiful as it ages. So ages gracefully. And software, just like other products in the real world, from time to time, it becomes brittle and certain parts have to be refreshed or renovated or even replaced. And sometimes you have to retire it and start over because whatever around the context of that device or application has changed. So at the center of this, you need management, you need leadership, right? And there's a clear difference between leading and managing. We won't talk about that here. So moving on to, what is the program we're offering here? A Master of Professional Studies in Software Engineering, and we'll talk about the coursework in a moment here. We also do have a certificate. This is not a focus of this presentation today. So if you look at the Master of Professional Studies, it's 10 courses, 30 credits. In other words, it is the same length as a traditional master degree, which maybe makes you ask the question, so what's the difference? And really, that's what we're trying to show here. The difference is not in the length of the program, or the duration, or the rigor, or the quality. The difference is on the emphasis. What is the program focused on? Software engineering is focused on the application, the profession, the impact of software on its surroundings. Computer science is more focused on theory, algorithms, and you can argue information systems is somewhere in between. Another way to look at it is computer science perhaps is akin to physics, where software engineering may be akin to medicine. So in other words, software engineering has a broader view, and it does overlap with computer science. Really, software engineering is about creating system of systems and understanding their impact, their legal and ethical impact, their security and safety profile, the complexity aspect of it. How does it align with the mission and the vision of a particular organization or a team or a country? So it's really looking above and beyond the simple things from a cost and a schedule, but looking at the whole entire thing. In other words, in computer science, we may be creating a module or a library or a small program or a small algorithm, albeit it's very important, but that's the extent of it. In software engineering, we're going to be building a whole entire building or a whole entire house, but we're not satisfied with that. That house, that building, that system must fit seamlessly and peacefully and harmonically with the rest of the other systems in existence and the ones that will come in the future. That's a tall order. And that's why software engineering is more important than ever before. So if we look at some of the authoritative work in software engineering, so this is Software Engineering Book of Body of Knowledge from the IEEE, the Institute of Electrical and Electronic Engineers. It's an authority on the subject here in the US. They define software engineering as 12 different disciplines that builds on top of 3 foundations. So you can see at the top, the 12 disciplines here: software requirements engineering, software construction, what we call software engineering, software testing, software quality, software engineering economics, and so on and so forth. And all of that is built on top of computing foundation, mathematical foundation, and also an engineering foundation. This is a tremendous resource that was reviewed by 100 reviewers in more than 30 countries. And this resource is something we use in teaching advanced software engineering course, for example. And we draw on this body of knowledge, this tremendous body of knowledge, to inform and give you the advanced skills you need to be very successful. The program is on our main campus. And so The classes themselves will be held in person. They may have multiple modalities, hybrid, some components that are online, both synchronous and asynchronous. Software engineering is a team's sport. Software engineering is a profession, and as a professional, you're expected to be able to conduct yourself in real life, in person, via video conference, as we're doing here, via a phone call, or all of these modalities all at the same time. So on to the actual program. As we said, 30 credits, of which 6 courses are core courses required, and the other 4 are electives. And so you can see here, we start with meaning, because our mission is to teach you how to create software that is first and foremost ethical, and then reliable, and then beautiful. That's really what is our mission in this program. So these courses speak to that. We start with meaning and ethics. Then we need to understand how to analyze and design a system via structured system method. And then from there, we go on to advanced software engineering. And then we wrap up your work with a capstone in software engineering. This would be a solution to a real world problem in partnership with a community member or a local company or a nonprofit or an idea for a new company or a startup. Along the way, we also have fundamental software testing. We talked about testing already, and a course on management and leadership and effective communication. So those are the core courses. And then if you look at the electives, this is a certificate, so we're going to skip that. If we look at, before I get to the electives, just looking at the program slightly in a different way, we call this a mind map. A mind map. So on the right-hand side, what you see are the values, the principles, the pillars, right, that this program is built on. Ethics, leadership and management, understanding a process or effective processes, and starting with excellence and ensuring high quality. On the left-hand sides are the how, the tools, techniques, the methods, if you like. Structure, system analysis and design, advanced software engineering. It's sort of the gem of the program. And then we're going to bring in advances and innovations and emerging trends from both the industry and research by using a special topics course that brings the latest into the classroom. And then lastly, as I mentioned already, is a capstone with a solution to a real world problem. Right, so let's take a look at core classes and elective courses. So we draw on courses from our sister disciplines, whether it's information systems, computer science, data sciences, human-centered computing. So that's what you're seeing here, along with engineering management. So if we go back to the software lifecycle and all the roles that we talked about, we can now overlay the skills, the knowledge, and the coursework on top of these. So for example, we can overlay 645, 636, and 638. Advanced software engineering, structured system analysis and design, and software process management. Interesting enough, all of these courses are being offered this semester. And then in the analysis phase, 636 again. In the design phase, 636 is an important course. We advise students take that in their first semester. Human-centered design, 629. And then in implementation, several courses, right? Advanced software engineering, capstone 701, 691 is the special topics and electives from computer science. And then in testing, of course, 740, which we're offering this semester. And then in maintenance, actually, we have faculty members in the information systems department and computer science who are experts in the area of software maintenance. So that would be 691 or information systems 800. And at the center, of course, in order for you to learn how to lead and how to manage effectively Engineering Management 652, and of course, Ethics, another course that we ask students to take in their first semester, Software Engineering 601. All right. The other thing that we did in this program to make it simpler for students to pursue a software engineering profession is to create clear pathways. And so we have three major pathways that someone can pursue. Software architecture. There's a shortage of software architects. These are software engineers who can see the big picture and can navigate the details as well. The other pathway number 2, is data engineering, not to be confused with data science. So data engineering is about the tools, the platforms, the ecosystem that enables data science. And then software engineering management. Software is created differently, and software as a product is a lot different than physical products. Not only that, but today we have this concept called software-intensive products. You'll be surprised what that is. Potentially your car, if you have a modern car, an advanced car, it doesn't have to be just electric car. It could be a software-intensive product. There are studies and some researchers that claim that some of these cars have a lot of code in them, a lot of software in them. Now, let me just say, more software than the Windows operating system, more software than Facebook, right? So the Windows operating system is about 50 million lines of code. Facebook is maybe 60 million lines of code. Yes, it's more than Windows, surprisingly. One of these modern cars could have 100 million lines of code. Now, lines of code is not a meaningful metric in every aspect, but this is just to give you an idea that software-intensive products can show up in areas that we do not expect, right? Two other pathways is consulting and training. There's a tremendous need for that, especially software engineering training and software engineering education. We look at the pathways here. These are the suggested courses. If you're going to be pursuing one pathway or another, you'll see that the fundamentals of human-centered computing is included in every pathway. Because again, what we're trying to create is ethical, reliable, and beautiful software. And for that, we must bring in that human connection first. We're lucky and blessed to have really an awesome faculty advisory board from computer science and information systems who gives us advice and also brings in a different perspective from research and their long tenure. So now you're probably asking, how do I apply for this program? Well, we made it simple. Really, only 3 things to qualify and apply, right? A bachelor's degree with GPA of 3.0 or higher. Now, the bachelor degree could be in computer science, information systems, or related field, or could be non-related field. The second requirement is some level of understanding of introductory programming courses, either through taking a course or through hands-on field experience. And the third one is fundamental aspects of mathematics, college level calculus or applied calculus. At UMBC, that would be Math 151 or Math 155. That's it. Simple enough, right? GRE scores are not required. If you are an international student, we do require proof of proficiency in English through one of these tests that we have listed here. The application process is also quite simple. 3 things as well. Official copies of your transcripts, and if English scores are applicable to you as well. Statement of purpose, which I will talk about in a minute. And then again, this is a professional program. We seek to bring to the world high caliber, first class, world class professionals. So your resume is important as part of the application package. There's a fee, but since you are here, you can get that fee waived by using the code on the screen. And to apply, you can go to gradschool.umbc.edu/admissions/apply. So now I want to just take a minute here and talk about the statement of purpose. It's important for you to tell us your story, to tell us about your background. Tell us why you're interested in software engineering. We're looking for students who are passionate, who are going to take software from where it is now, which is a good place, to a great place, right? And we want to know why you're interested in UMBC, right? And if there are things in your experience or background that needs clarification in terms of meeting requirements, make sure that you mention that as well. This statement is your statement. It needs to be your voice. It needs to be personal. We need to feel and read your passion in it. And so speaking of passion, really, software in many ways is invisible, right? But that's what makes it so magical, right? The software kind of breathes life and brings hope into the world, into the hardware, creates many possibilities, right? Early on, we showed you that, many countries have products they export. Software can be exported from any country by any person. The barriers to entry is very, very low. However, there's only one barrier for entry, that is drive, passion, the desire to create something new, the desire to improve something. And so you, I, everyone, all of us can be part of this journey, can be part of this story. And that brings up us to the bonus raffle. So I'm going to pause here. I'm going to hand it over to Jeremy, who will do the raffle for us. Jeremy?
Thank you, Mohammed. And thank you again for joining us, all of you. We will momentarily get to our open Q&A portion. But first, it's time for us to have our live drawing of which of you is going to win our open house scholarship bonus. So I have the names in a cup here. We're going to give it a quick shake. I know I apologize for the old-fashioned method, but sometimes it's more reliable. We have Gabriel. So I can see that you are with us. Actually, our assistant director, Stephanie Allen, will be in touch tomorrow with exactly how to make sure that you qualify for the scholarship and all of that. But congratulations for winning our drawing tonight.
Wonderful. Congratulations. Okay, on to thank you all for listening. Thank you for being here. We're really excited that you decided to come and join us, and happy to answer any of your questions. You can see here the shortened URL to learn more about the program, seng.umbc.edu. If you have any academic questions, happy to answer them. My email is on the screen, msamar@umbc.edu. If you have administrative type questions, send those to softwareengineering@umbc.edu. Again, you can use DPS 2023 to get the $50 application fee waived. And we encourage you to apply, and we would love to have you on board. With that, I'm going to hand it over to Jeremy, and we will take questions.
Thank you again. And to answer one frequently asked question, we will share the recording of this presentation. It'll take us a little bit of time to get it out to everybody. But since I know there's a lot of information presented in these slides, we will get all of that out to you. The application information can also be found online at seng.umbc.edu, or if you email softwareengineering@umbc.edu, I'm usually monitoring that email, and I'll be happy to talk to you. Thank you for the question, Syed. For English proficiency, we are accepting Duolingo.
Yes.
UMBC's minimum score is 115 on the Duolingo test. Funding opportunities. So we have very limited funding opportunities available in general. Unfortunately, international students are generally not eligible for very much U.S. financial aid. We do not have general scholarship programs, and assistantships at UMBC are very limited and almost never available to incoming students. Occasionally, to returning students who have experience in their courses might be asked for a teaching assistant position would like. Broadly speaking, we recommend that you plan out your studies without any expectation of funding from UMBC. But some students are able to secure, again, very limited positions on campus.
Yeah, I echo that. Obviously, we try to help students in every way we can. We do have some limited graduate assistant and teaching assistant and grader type of positions, but typically the first semester or the first year, those are hard to get, especially for a new student.
There is a program on campus. It used to be UMBC Works. I apologize. I believe the new one is called Handshake. We're actually just changing over. That's essentially a job postings board that's available only to UMBC students. Obviously, international students, because of visa requirements, have limitations on where you can work, but some of those postings are on-campus opportunities. That's managed by our Career Center, as similarly are a lot of internship programs. Thank you for that additional question there. If you are an enrolled UMBC student in your first semester, you gain access to that portal and can search for opportunities. But the software engineering program does not place you in an internship, nor do we require internships.
Yeah, so opportunities that are available, they're limited, and it's possible for some students to secure them, but there are no guarantees, and we encourage you to have your own plan. But nevertheless, there are some opportunities.
Decisions for the program. So we are just starting our fall semester, and as such, we are just getting started on reviewing applications for the spring of 2023. This is rolling admissions, but please understand that our faculty have to review an unprecedented number of applications. There's been a lot of interest in this program, especially from international students. We would say about 4 to 6 weeks, most likely from today, assuming your application is complete. I apologize, I don't remember off the top of my head whether your application was or not, but I assume it was. That includes both the review by the department and then a subsequent review by UMBC's graduate school. So there can be a little bit of processing time as we're getting started in this spring application review. Thank you for that question. If you have academic questions or questions about how this program would fit into industry, please contact Dr. Samara, MSAMARAH at umbc.edu. If you have administrative questions or questions about the application process, please reach out to softwareengineering@umbc.edu or directly to me, jeremy.matthews@umbc.edu. And again, that's Special Populations Code DPS 2023 to waive the online application fee. If you have issues with that code, please do reach out to me. It can be a little unintuitive. All right, I don't see any more questions coming in. So one final time, thank you all for attending. Thank you, Dr. Samara, for the presentation. And I hope to hear from all of you soon.